thing you're supposed to do? Factor. So once you factor this thing, do you agree with the factored form?
Yeah.
How does that look? Does this look okay right here? Okay, so the factored form is okay. So before you cancel, what do you find? The domain. Before you cancel, you find the domain. So what are the things that you can't plug in for x? Those are the numbers that would make the denominator 0. So those two numbers are going to be -5/3 and -2. Because -5/3 makes that 0, -2 makes that 0. With me so far? Then you cancel, and you can get the vertical asymptote. What's left after you cancel right there? Well, x plus 2, what makes that 0? -2. So what is the vertical asymptote?
-2.
X equals negative. What is x equals -2? Where is it? It's at x equals -2. How do you figure out what the, what else do we have here? What is that? Is that the hole right there?
Yeah.
The hole is the x where it cancels, right?
Yeah.
And how do you go about finding this -11? Where does that -11 come from?
You enter -5/3
Yes.
into the cancel.
Into the cancel, you take this and you plug it in right there. You -5/3 -2, -5/3 +2, and that comes out to be -11 when you cancel, when you simplify it. You need to be able to work with fractions. So when you do that out, just -5/3, what is it? Is it -2 on top? Over -5/3 +2. To add fractions, what do you need? Yeah, so you have this -6/3 over -5/3 plus 6/3. So what do you end up with here? -11/3 over what? 1/3. So that's -11/3 times 3/1, which is -11. Oh, that's the work that was right there next to it. Thanks. You're like, fine, he's going for the overkill. He likes 2 colors on everything. That's all it's asking you for each of these, I think, right? Yeah. Can we find more? Sure. What's one thing we could test for that hasn't been written down in any of these? We could try to find where it what? Like what are? There's a few things left. You could do y-intercepts. You could do x-intercepts. And there's something else we could do as well. We could check something. Check if it crosses what? The horizontal asymptote. We actually didn't even find the horizontal asymptote. What is the horizontal asymptote on this one? You can just tell me what it is. It's y equals what? Close. Look at the 3x squared over 3x squared is 1. So the horizontal asymptote is 1. And you could check to see if it crosses. What do you think? Do you think this one crosses? X minus 2 over x plus 2 equals 1. Is there any way to make x minus 2 over x plus 2 equal to 1? No, because is there any way to make x minus 2 equal to x plus 2? Yeah, if you have x minus 2 and x plus 2, the x's cancel and you get 2 equals -2. So does this cross the horizontal asymptote? No. You generally need higher powers for that to happen. Okay, other questions from the... Just be really careful about finding those points. Like if you know that 5 is the only x-intercept, then you know it can't cross anywhere else, so it can't. So for example, you will see graphs that look like this. It'll go up here and then cross and come down. Yeah. But if you only know it crosses there, you know it has to bounce back up.
I had it crossing there, but I didn't have it coming back.
Yeah. The harder it is to factor, right? So if I were to multiply that out, that would be a 3rd degree polynomial. You have spent some time factoring those. Rational zeros theorem, like you test zeros, right? So like, for example, to factor these, you need to find that 2 makes it 0, 4 makes it 0, 6 makes it 0. But here's the thing, what happens with this one? What happens? They all cancel, right? Are there any vertical asymptotes? No. This is the graph of what type of line? Y equals 4. What is that? That's a, what's that called? It's a horizontal line, right? But what do these 3 things mean they're going to be on that? 3 what? 3 holes. It's a horizontal line, y equals 4, and there's a hole at 2, 4, and 6. Yay! So what should I do first? What? Oh, unfreeze first. Good. That was the proper first step. I like it. Okay, what's the first step? Go ahead, factor. So let's factor. Yeah. Who wants to lead me through factoring? Someone else. Who wants to lead me through factoring? Arvin, go. Yeah, what is it?
So x minus 3.
Yep.
Times x plus 5.
Over
x minus 3 times x plus 2.
X plus 2?
Yep.
Nice. So now what's step 2? What do we want to do next? Someone else who hasn't spoken yet. Alex, what do I do next? What do I find? After I factor, I find the...
X and y intercepts.
You could, but I'd like you to do first the, begins with the D.
Domain.
Yeah, so can you tell me what the domain is on this?
All row numbers except for 3 and -2.
Correct. Nice. Now you can cancel. So what cancels now? What cancels, Natalie?
X minus 3.
Excellent. So if we cancel, after we cancel, what can we find now? The whole, exactly. If there was so whole, and that's going to be x equals 3, and then you plug 3 in, and what do you get? 8 what? 8/5. Nice. So after you found a whole, what can you find now that you have it totally simplified? Junior, what could you find next? Intercepts. Sure, you could do intercepts, or yeah, intercepts are fine. So if we do maybe the x-intercepts, that's when the output is 0. So that's when this is 0. What makes it 0? What's the only number you can plug in to make it 0? Negative what? That's the denominator. You want it the numerator. Negative what? And why don't I say 3? Why don't I say 3, 0? Why don't I say that one? It's the whole. It's not in the domain, right? You can't do that, right? So if we have the x-intercept, can someone tell me what else I could find? The y-intercept. And that's just when x is 0. When x is 0, what do you get out?
5 halves.
5 halves. Nice. We have 5 halves. And then what's the last thing we can find? Which, yeah. So the vertical asymptote is going to be at x equals what? And what's the horizontal asymptote going to be at? What's the horizontal asymptote? 1. Look at the original. X squared over x squared is going to be 1. So is that a ton of information right there? That's a ridiculous amount of information. So let's put the asymptotes in. Vertical asymptote at -2. I like to label it x equals -2. Horizontal at 1.
Wait, how'd you get horizontal?
X squared over x squared
Yeah.
is 1. So when x is huge, it's the same thing on the top and the bottom approximately. So what's the same thing over the same 1? It's a nice way to write 1. Okay, so that's y equals 1. What should I next label on here? The what? What should I next label? Yeah, so we labeled it. How about the intercept? So -5, 0, that's right there. And where's the other one? 0, 5 halves. So where is that? Like right here? Is that correct? Looks pretty good. There's one other point I could label, which is what's the point I could label? The whole. I could label the whole. So where's that whole going to be? 3 8/5. So is that below or above the horizontal asymptote? Above. So 8/5 is that almost 2, right? So it's right about there. Is there a line draw tool? There is a line draw tool. Practice using it, and it'll make your graphs real nice. I'm not very good at using it because you have to drag it like at one point and then the other, and then kind of move the line. But it makes them look. I've had students that are awesome at the line draw tool, and their lines look a lot better than mine. What's one other thing we could check just if we wanted to? What's one thing we could check? Crosses the horizontal, and we can check that this thing would have to equal what? 1. Does it equal 1 ever? It really doesn't. 5 never equals 2, right? 5. You can't do anything to the top and bottom the same thing to make 5 equal 2. Does that make sense? So it doesn't cross. So do we have a pretty good idea of what this looks like? Yeah, we have a pretty good idea. It could be, we know it's going to do this and that. And then what's it going to do here? There and there. We know it has to do that because it can't cross the horizontal asymptote, and we know it can't cross the horizontal asymptote, and by definition, it can't cross the vertical, or it wouldn't be a function. Does that agree with look at that. Oh, we got to flip that up a little bit right there, right? Just flip it up. If you get 1 or 2 values off, but this is generally pretty good. I like this. I like this a lot. Good job. Well, right now, the only thing I'm ever going to throw at you for factoring cubics is by grouping. That's really the only thing you have in your back pocket right now. So if you see cubic, it's either really nice, like super nicely factorable, like something super obvious. And I know that's a terrible word to use. I hate using that word in math classes. Clearly and obviously are terrible words. Why? Well, let's say you're working on a question in your book, okay? Let's say you're working on a question in your book, and it says like, clearly, the answer is this. Either you understood it already or you don't understand it and the book isn't kind of like insulting you, right? So like if you ever have a book say clearly, like it's not good, okay? So factor the top. What did you guys factor out first, Lindsay? What did you factor out first out of the top? Yeah, when you see easy things to take out, take them out, please. It makes things so much more straightforward. Generally speaking, the smaller something is, the easier it is to factor. So that turns into 5 times what? X plus
4
x minus 2. Nice. And then the bottom, what can you factor out of the first 2 terms? X squared, and you get x plus 3. And what can you factor out of the next 2? Negative 16. Why do you factor out negative 16 instead of positive 16? Yeah, you need the same unit, right? You need the same x plus 3 and x plus 3. If you factored out positive 16, you'd have x minus 3, and that doesn't really get you anywhere. So next, we end up with x squared minus 16. Those are the first two coefficients, and both of them are multiplied by x plus 3. So the first thing you do is domain. What is the domain, Lindsay? Oh, can you factor that a little further? Yeah, what's the denominator? Yeah, there you go. Thank you. Nice. And then it's the same. 5 times x plus 4 times x minus 2. Nice. So what's the domain? X such that what?
X cannot equal 4, -4, -3.
-4, 4, or -3. Nice. So then what do you do next? What's that next word, Lindsay, we look for? We can do what?
Oh, cancel.
And then if we can cancel something, what does it give us?
A whole.
A whole. So you know that's going to happen at x equals what?
4.
-4. And then you take -4 and you plug it in. And did someone get the, what is the y value when you plug in -4? -15 over 4? So about -4. So next, after you find the whole, there's a bunch of different things you can do. What could you do next? Arvin, what could I do next after I find the whole? Yeah, I like vertical asymptotes. That's what I would do. So that's going to be x equals what, Arvin?
X equals
what?
4.
Yep, and x equals?
-3.
Nice. And then a horizontal asymptote. The denominator's degree is what? What's the degree of the denominator? What's the degree of the denominator? 3. What's the degree of the numerator?
2.
If the degree of the denominator is greater than the degree of the numerator, it's always going to be y equals 0. Yes. So you have that. Now, what haven't we found yet? The x-intercept and the y-intercept. The y-intercept is when y is 0. So you look at the simplified form. What's the only number that makes this whole thing 0? That makes the whole output 0. What can you plug in for x to make everything go to 0? Look at the numerator of the simplified form. 2. So you know it's 2 comma 0. Are there any other x-intercepts? Are there any other numbers that make the numerator 0? Nope. So y-intercept is when you just plug in x 0 for x. If you plug in 0 for x, what do you get? Yeah, you get what is it? -10 over -12. So what is that? 0.56. Yes. So you plug 0 in. Do you have a ton of information now? You have a ton. So if we were to do these asymptotes right here, let's do I like starting with the asymptotes. What are the asymptotes here? We have x equals 4. So there's one asymptote right there. Where's the next asymptote? X equals what?
-3.
Thank you, Noah. -3. X equals -3. And then we need to label our maybe intercepts. So we know it's at 2, 0 right there.
There's also
Oh, but then there's also, hey, we already showed that, so look what we just showed. It does cross once, right? And then what's the y-intercept? 0 what?
10, 12, or
5, 6. So it's a little less than 1. It's right there. And is there a hole somewhere?
Yeah.
Where is it?
-4, -15.
Yeah, so -4, almost -4, right? So like something like that. So if we have that information, what does it look? Can we cross the x-axis anywhere else? This is key. You can't. So what does it have to look like in the middle? It has to go up, and then what does it do? And then it goes down. And then this one has to go down. Why do we know that has to go down? Well, look, if it went up, what would it have to cross? And we also know, what's the degree of this thing right here? The x plus 3 degree is 1. So that's one opposite direction. If this goes up, this one has to go down. And can this cross this horizontal asymptote? No, because it only crosses at 2, 0. So this goes up like this. And if this one goes down, what does the other side have to do? Go up. The only other things I'd like you to, what make that y equals 0 right there? That would be perfect right there. That would be excellent. I love you labeling things, label things. Another way to label things, by the way, this is really important because you can do this on the AP test as well. Instead of trying to cramp in like arrows and stuff to label what the points are, you could literally do this. This is point A, this is point B, and this is point C, right? And then you can say, okay, so that's point A right there, right? Where's the B is the y-intercept, so there's point B, and the x-intercept is C. That's awesome right there. Much cleaner, much cleaner. Let's do a little bit of this. Who factored the top? How do you factor the top? What? Grouping. You can factor out 2x squared, and what do you get? X plus 1, thank you. It's frozen. Yeah. Okay. X plus 1. And then What do you factor out from the second 2?
-8.
So minus 8 times.
X plus
Why do you know you're in a good place at this point? Why is that awesome? Two of the same thing, the x plus 1s. And then can you flat out just straight factor the denominator? X plus 2 times.
X plus 1.
So what does this factor into? 2x squared minus 8 times x plus 1 over. And are we done factoring?
No.
Say no. What can you factor out first on the top?
2.
2. X squared minus 4. X plus 1 over the same thing. So can you factor something still?
Yes.
Yeah, it's a difference of what? Squares. So you have 2 times x plus 2, x minus 2, x plus 1 all over x plus 2 times x plus 1. So now that it's fully factored and you're all happy and you're like, yay, that's awesome. What do you find first? Domain.
X equals all real numbers.
Yep.
Except for -2 and 1.
Exactly. Nice, Andrew. -2 and 1 and -1, right? Any holes? Are there any holes?
Yes.
Yeah, because you can cancel 2 things here. What are the x values of these 2 holes?
-2 and -1.
-2 something and -1 something. How do you get what the other points are, the outputs? You plug them in. So it's -2 into what's left. So it's 2 times -4 is -8. And 2 times -3 is -6. You have 2 holes. Are there any vertical asymptotes, anybody? Any vertical asymptotes? Nope. Because what's the denominator now? 1. There's no hole. What about horizontal asymptotes? Are there any horizontal asymptotes? No. What is this functionally? This is a what? When you graph this, what's the only thing that's left? The 2 and the x minus 2. What is that? What's 2 times x minus 2? What type of function is that? Is it a quadratic?
It's,
What is it?
it's quadratic.
No, it's not.
No, it's not.
No x squared.
It's just like
It's a linear. It's a line, right? What's the slope of the line?
not.
What's the slope of the line?
Slope of the line is
So this thing is 2 times x minus 2. What's the slope?
like -2, right?
No, just 2. What's the x-intercept?
Y on X.
Yeah. We have the x-intercept and we have the y-intercept. The x-intercept is when y is 0. So that's going to happen at 2, 0. And what's the y-intercept going to be? What's the y-intercept? No.
0, -2.
No.
-4.
-4. Plug in 0 for x. You got this. You got this. What does this turn into if it helps you? This is 2x minus 4. Oh, yeah. So we graph this sucker. -4, it crosses there, it crosses there. And here's the line. But what do I need to plug in here that's really important? What have I not drawn? The holes. How many are there? So we have -2, -8. So right there. So that's this point, A. And then we have the point -1 what? So that's B. So then you can do, there's different types of erasers, by the way. Do you know about that? There's like, you can change, what is it, draw. You can change the eraser to what, like small eraser, and then go, I'm going to zoom in here, and go, doot. Is this right there, and then that right there. How do you feel about this one?